Hi everyone. This problem is about conservation of linear momentum. So we have two masses, 0.04 kilogram moving with the speed of 5 meters per second. That's the first mass, M1, that was moving with the speed of 5 meters per second, the velocity. It collides with a bigger mass, M2, which is 0.06 kilogram, also moving at 3 meters per second, V2. So we write here V1 initial, and V2 initial is 3 meters per second. What will be the velocity of each mass after the collision if the two masses are moving in the same direction? So they are moving in the same direction as shown here. This is before, and we need to see what's going to happen after they collide with each other. For sure, the M1 will hit M2 because M1 is faster than M2, as it's clear here. Now, logically, when M1 hits M2, logically M2 should now move faster because it gets a collision from behind. So M2 is going to go faster. So its speed, the V2 final, you can say here, V2 final should be greater than 3 meters per second, logically. All right, no way it could return back. This is regarding M2. So in one of the options, the first option is cancelled because no way the velocity could be minus 2.4 meters per second. No way M2 could go left. It should continue going right. So we are left with three options. Now, let's see what's going to happen to M1. As M1 hits M2, again, logically, as M1 hits, let's draw the velocity. As M1 hits M2, then M1, because of the collision from the front, now it should go slower or return back. So it should go slower, but no way it should go bigger than 5. So V1 should be either to the right or to the left and should be slower. If it's to the right, it should be slower than 5 meters per second. It should slow down. So again, when we look at the options, we can see the second option, V1 is 5.2 here, which is bigger than 5. No way it could be bigger than 5. So also we cancel the second option. We are left with those two options. Common sense tells you that this M1 should also continue to go straight to the right with a less speed. So it's going to be this option. But let us prove it mathematically, why it's going to be this option. While this one, as you see, minus 1.6 means it's going to return back. So let's see why it should be the third option. In conservation of momentum, in addition to the law of conservation of momentum, which you already know, where momentum initial, M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final, we have another law, which is the relative velocity. The relative velocity tells you that V1 minus V2 initial should be equal to V2 final minus V1 final. This is a very important relation in elastic collision only. This is true for elastic collision, as in that case, elastic collision. Okay, so let's see what is V1 minus V2. If you go back to the figure, V1 minus V2 means 5 minus 3. So it should be, so V1 minus V2, it is 5 minus 3, which is 2. Now, if you check this option here, let's check this one. V1 final is 2.6. So let's check here. V1 final is 2.6, I have minus sign here, and V2 final is 4.6. This one, V2 final 4.6. So here I have 2, and on the other side I also have 2, which is true. Then this option or this choice is correct. For sure, if you try the last choice, you will get a wrong answer for this equation. Thank you for watching.